Alright, welcome. So today we're going to be doing Proving Grounds. Dawn 2. I'm going to edit a video for YouTube like real quick. Jay, how you doing? Proving Grounds, Dawn 2. Save that. So yeah, we're going to hit up this one, and then if we have time, we might hit up one more. So I was told there was a ROP exploit for this VU player, and so I downloaded that on Windows 7, had all ready to go, started doing the ROP exploit, was all into it, and then realized like, this isn't ROP, this is, you know, just a straight up vanilla exploit. So yeah, straight up, yo. So I did that one, and I was like, that's weird, so I still gotta do a ROP exploit. Hopefully we can find one. But yeah, we're gonna do Dawn 2 today. I do have Windows 7 already open, along with obviously Kali here. So we'll go through this guy. I'm just waiting. Why is it stopping soon? Refresh. We should be starting soon, not stopping. Dawn 2. Stopped you like 5 hours ago. Yeah, like I said, we already have Proving Grounds up and running and everything, just waiting on pretty much Dawn 2 to get up and running. So this will be a good one for your buffer overflow prep for OSCP or ECPPT. It is obviously on Proving Grounds website, so that's obviously a plus, like right there. And this has been successfully stopped. Why is it stopped? Your VPN is disconnected. You are a liar. You lie like a rug. We'll go ahead and try that one more time. Start that guy back up again. You lie like a rug. Let's go ahead and disconnect it, and we'll reconnect into it. How about that? Do something like that. See if that works. Am I still connected? Yeah, I'm still connected to the internet. Obviously, I'm streaming like right now. But hey, even doesn't work, we show you both the exploits still. That's the nice thing about being able to download the exploits on your own machine. You can still run the exploits, but just want to be able to get the flags. That's all. Solstice. What are you talking about, Solstice? All right, Dawn 2. Here we go. Play. Preparing. Starting in 43 seconds. So while that guy's starting, I'm gonna go ahead and fire it up on my Windows machine and get that one all ready to go and everything. So we're not really waiting on that, since we only have so much time in this box. So let me make sure this Windows machine is also fully in here. Yeah, it looks like it is. Boom. Boom. There we go. All right, cool. So we're gonna go ahead and fire him up on this Windows machine here. So we got our Dawn, like right here, which you are able to download. I'll show you where to download that and everything. And we'll go ahead and run it. And it just says the server is started. The server is currently listening. All right, that's something new. Obviously, even if Dawn starts, I'm gonna be doing everything from my local machine, right? So I'm not gonna do anything from Dawn just yet. So I'm not gonna be using my IP address that I have for my tunnel. Right, I'm gonna be using my local IP address. So if I do an ifconfig, I'm going to be using my 192.168.0.21 IP address for now. And if I head over to Windows, which you guys are already looking at, I'm going to go ahead and do an IP config over here. And I'm obviously going to be tacking 192.168.0.35. So let me go ahead and hop back over into Kali here, and we'll do an Mmap scan of 192.168.0.35. And simultaneously, we'll also do an Mmap scan, see if we see any of the same ports, because a lot of ports are about to show up on here. Of 192.168.214, it looks like, .12, which is going to be the actual box's IP address. So we'll go ahead and start up that one, and we'll start up this one. We'll see if we get any of the same thing here. Should have also tried done a Rust scan. Might just do a Rust scan. And that machine may not even start it up yet, because I know he does have a port 80. So let me go ahead and do a Rust scan of both these guys, just because usually whenever we're talking about buffer overflows, you're usually talking about weird ports, higher up ports, things like that. Let's go ahead and do a Rust scan for both of these guys. 192.168.214.12, at least that's what it looks like. 214.12. we got this port 1985 in there. That's a weird one. The other ones I already know about. So 214.12, yep, that's him. And we are running on him like right now, right? Because he's not finding anything from down there. Run a scan for that one. He may also just not be up and running yet. It may take him a minute, or maybe mess it up because we already had one mess up here with Dawn 2 earlier. But while that's trying to get figured out over there, actually we can try to also go to the web server for it, see if that's up and running. Doesn't look like it because the rust scan's not getting anything. You would have at least found that on port 80 there. Yeah, he's not finding anything on him, huh? Let's see here, can we ping him? We cannot. So I wonder what's going on with him like right now. So we can't even ping him for some reason. Might have to stop him and start him back up again. I think I'm going to do that. And while we're waiting for him to stop and everything, we'll go ahead and we'll start to work on our exploit. So I made a little exploit shell here for everybody. We're just going to import socket, import sys, import OS, the IP address. So right now we're going to be attacking 192.168.0.35. We're going to be attacking port number 1985. All right. Offset right now is 0. We don't know what the offset is. We're going to send 300 A's at it to start with. Now I did notice that if you send too many A's at this guy or too much information, it will look like you can do a structured exception handler overflow. But what the problem is once you start that overflow, you'll realize very quickly you don't have enough space to actually put in any type of exploit in there. So you'll start the overflow and then you'll look and you only got about 30 bytes, 40 bytes maybe afterwards. You might be able to put in a Linux reverse shell in there, but you wouldn't be able to test that on your home, obviously my Windows machine. So that's why I started bringing this guy back down. I was able to do 300, and I noticed that 300 is about the sweet spot for this guy. So that is something you want to realize, that just because you sent 2,000 at it and it broke at 2,000 doesn't mean that 2,000 is correct. Start to work your way back down, especially if you're not fuzzing it and you're just setting them off. All right, from there we're going to s equals socket. All right, socket stream. Then we're going to do a connect into IP, which is obviously 192.168.0.35. Then the port 1985. All right, fire thy missile. All right, and then whatever the buff says. Okay, so buff A times 300. Send that off. Print finished. So if you can't find it, it's just going to say, hey, I couldn't connect to it. Now we did do a scan on him also, right? So if we actually come back over to my Windows machine, you actually see that Vault Server, or not Vault Server, excuse me, Dawn is not running anymore. So if I open him back up again, and if he's not running anymore, let me go ahead and not open him back up, because as soon as he got scanned, he actually shut down. So that's something to realize whenever we start to work on it externally. Because if I do that rust scan again on 0.35, you'll see that port 1985 is missing. Right? He's not there anymore, right? So that's something to realize whenever you start to work on this guy externally, and you're like, wait a minute. So let's go ahead and try to ping him now. Still not able to ping him. Don't know what's going on with that guy like right now. I might have to do this again over here. Get out, go back in, or whatever else. But we're going to go ahead and exploit him anyways. We're going to stop this machine because we don't want to waste our time with it, right? We don't want time to be wasted as we're sitting here doing that. And we'll go ahead and also stop this too. And we'll reconnect into that too, just in case. But let's go ahead and exploit this guy. So we got all this. So we can fire off that buffer, right? So we named him exploit.py. So if I do an ls-tech-la here, we can see I already have exploit.py right here. Now something I also did was I did a cat on readme.txt, and I realized that this thing says, due to the lack of implementation of the Dawn client, many issues may be experienced, such as the message not being delivered. In order to make sure the connection is finished and the message is well received, send a null byte at the ending of your message. That's information that we need, like right there. We need to know to send that null byte, because null bytes, we know we don't ever want null bytes in our exploit, right? So let me go ahead and go back into Sublime on exploit.py, and let's put a null byte in there. So let's do a buff plus equals, and that's going to be a /x90. or excuse me, a null byte x00. Alright, we're just going to put just one in there. So now we have that null byte in there. Let's go ahead and Control S to save him. Let's hop back over into my Windows machine, and then we'll fire up the exploit and see if he crashes. So let's go and hop back over in here. We'll go ahead and open up Immunity Debugger. Yes, please. Control, nope. Control F1, nope. Control F3. Oh god, it's going to attach something. Oh god. File, open. There we go. Let's just open up, let's see here. We got our C drive, right? Or not our C drive, our desktop. And then we're looking for Dawn, correct? So looking for Dawn. Enter. Yes, please. Alright, there we go. So let's get this guy up and running, F9. Alright. Now, on some of them also, just so you guys know, you may also be able to find the port over in this area. So you may be able to look over in the CPU register area and find a port. I think this is as big as the text is, right? Is this the big text that I usually use? Appearance, font, 6. Yep, that's it. Alright, so let's go ahead and fire out that exploit now. I'm just going to go back to my Kali machine, type in python exploit.py, and you should see him crash over there. Should, hopefully. Alright, he fired that missile. And he did crash. We have a paused over here. Alright, you guys can't see that. There you are. Paused. Okay. And now what we can do is we can go ahead and we can see, did we overwrite the EIP? And sure enough, we did. 41414141. So we know we can overwrite the EIP. So if we know that we can overwrite it, we can go ahead and do a Mona pattern create. And that was going to be 300, right? And this guy's going to create a pattern.txt file. Yes, we are using Mona pattern create this time, not MSF pattern create. But that's did you connect to VPN? I did connect to VPN. But that's going to create that pattern.txt file. Now, one thing to get used to is going into actually Immunity Debugger's home folder and actually finding that pattern.txt. So when you start to do bigger ones, it may not all fit on this line like right down here. So I'm going to go to my C drive, program files, Immunity Incorporated, Immunity Debugger, and then we'll go ahead and we'll scroll down and we see that, where's that? It should be pattern, right? If I knew how to spell, there we go, pattern. If we open him up, we can see this, like right here. We'll grab that ASCII pattern, and we'll go ahead and try to figure out where this guy actually crashed at. So we'll grab him, we'll head back over into my Kali machine, and we'll see where did he actually crash at, right? So let's go ahead and sublime text that exploit.py. And instead of 300 A's this time, we're just going to go ahead and actually stop him. Boom. And we'll do a buff plus equals, or equals, excuse me, because we stopped that one up there, right? So we have no buff equals. And we'll throw in that pattern. Don't forget to put your quotation marks around it, and there we go. So now we have that pattern, and then we also have our null bytes at the end there. So let's go ahead and Control S that guy. Boom, boom, boom. Okay, so he's saved, right? We'll hop back over into my Linux machine over here, and we will start him back up again. So let's do a Control F2, yes, F9 to have him running again. Right, you actually see him, boom, there he goes. Okay, he's up and running everything. And all I'm going to do now is go back into Kali, type in python exploit.py, and that'll send it off. Alright, so fired thy missile. There we go. It paused, and it paused at 316A4130. Alright, let's go ahead and grab that. Let's go ahead and copy that selection to clipboard. And let's see if that's a thing. Okay, so we're going to do a Mona pattern offset. Enter. And it looks like the offset is sitting at 272. So now that we know the offset, let's update that in our Python script. And we'll do a sublime exploit.py. And we'll go ahead and delete this whole guy. Well, actually, we can just do this. And it was 272, correct? Not 292? Yep, 272. Okay. So we can say A times the offset. And the offset is 272. We can go ahead and make that buffer good again. We can either do a little pound sign there, or we can just delete this whole thing. We don't need him anymore. It doesn't matter. All right. Now what we want to do is we want to make sure that, hey, that is the actual offset, right? So we're going to do a buff plus equals 4Bs. And then we want to see, do we have enough space afterwards to put a payload? Because if we don't, we're kind of screwing that area, right? So we'll do a buff plus equals C's times, and we'll say 500. That should be plenty of space to put any type of payload in there or shellcode in there. We'll go ahead and save that. All right. Let me head back into my Windows machine here. Get that guy all started back up and everything. Control F2. Yes. F9. He's up and running again, right? And we'll go ahead and we'll fire this off and see if this EIP value changes to 42424242. You guys know before I do, and it did. 42424242. Now we can look down here and we see, okay, there's our A's, right? So we should have 272 A's. We got our 4 B's, that's our EIP value, right? And then here's all of our C's. So it's looking like we can fit 600 C's in there, or 500, however you put. That's a lot. That's plenty enough to do a buffer overflow. So now let's go ahead and find some jump points, and we can also look at our bad bytes. So let's go ahead and do a Mona jump, tac R, ESP. We'll find some nice jump points, see what we can get here. We found 2. Looks like we're using the first one, I guess. So we'll just use that one. And we'll go ahead and grab that jump like right there. We'll copy that to clipboard. We're just going to copy just the address there. And then we'll head back over into our Python script, right? And we'll update that address. So we'll do our sublime exploit.py. We got our A times the offset. And then we have to go ahead and do a buff plus equals the address there, right? And our address, we can say jump is that. All right. So let's go ahead and update him with a nice little address there. We'll do a /x BA. Remember, it is little endian, so we're working backwards here. /x64 /x59 /x34 it looks like. Okay, so there we go. We can get rid of these B's now. We know that those B's are good. Whatever. We're going to go ahead and say, hey, we're going to take C's, and we're going to make it even bigger. So we're going to take the C's. We're going to say, hey, I want to do 1,000. Well, we'll say times 1,000 minus the length of the buffer, or minus the length of offset, Alright, we go ahead and do that. Now let's go send 700 somebody sees that, so maybe we should actually bring that down. Let's bring it down to 900. Now let's go send 600 somebody sees that. 900 minus 272, whatever that is. Alright, so we'll go ahead and do that, and we still have our null bytes in there. So now let's see, do we actually jump to this point, right? Do we actually get there? Okay. Do our C's end up there? So let's save that, and then from there we can do the bad bytes, and we'll be pretty much golden after that. After that, we're just gonna kind of just hop in and do our thing, right? So let's go ahead and there we go. Control F2, yes. F9, cool. All right, let's go ahead and fire off that exploit. Remember, I'm just typing in Python exploit.py. Nothing crazy here, and he's not able to do that because integer has no length. Okay, let me go ahead and I'm just gonna get rid of that little C thing that I did there. I'm just gonna say times 900 or times 500 still, just so I don't have to mess around with it. It's because the integer has no length for offset, whatever else, minus the length of the offset. It should have been minus the length of, should have been offset, but I don't know. Didn't like that at all. So let me go ahead and do a Python exploit.py. It fired him off right, and we have now, there we are. Okay, and let's make sure if we go ahead and look around, nothing's looking funky, right? Everything looks real good actually. Alright, and that is right where we jumped into, correct? 345964 BC. That was our jump address. Let me make sure of that. 345964. Okay, he's got BC. We're jumping into BA, so yeah, we're good. Because that BA would fall into that BC. Okay, so we should be good for that. That'll be our NOP sled or whatever else. We use NOP sled to get into there, right? And everything. And yeah, we look pretty good now. Okay, so it looks like we got that guy, so he is definitely going to be able to be overflowed. So now let's go ahead and add in some bad bytes there. Alright. To add in our bad bytes, we're going to Control F2. Yes, F9. We'll get them up and running immediately. Head back over into my Kali machine here. Alright. Get you guys back over here also. And we'll go ahead and do a Python 3 bad characters.py. Now, let me show you what I do with my exploit. Cat exploit.py. So I got rid of that part with the C, like right there. I just leave it off. You could do, should be C times whatever number is minus the length of, yeah, that should have been correct, whatever I typed in. I'll just have to mess with it for a minute. Yeah, so that just took that off because we don't really need it in this one for this scenario, like right here. But there's my bad characters. Let me go ahead and cat that bad characters.py. Leave that up for a second so you guys can see, okay, cool, that's the Python script for it. If you follow along with the buffer overflow room that I did, try hack me, that bad characters.py script is in there. So let me go ahead and Python 3 that bad characters.py. We'll copy all those guys and we'll go ahead and throw them into our exploit. So now we're going to do a sublime for exploit.py. Instead of C's this time, I always like to do it after my jump because then it's like, does it work in that jump point? You know, that's how I always look at it. So instead of C's this time, I'm going to throw in those bad characters. And remember, we're still leaving that null byte in there, which is a bad character and will end the script. So if you also remember, we already started back up again. So we'll go ahead and just send him off. Python exploit.py. He fired off. Cool. So let's go ahead and hop back into my Windows machine. And we'll look at the ESP. And we'll follow that in dump. Okay, now what we're doing is we're doing our eye test right to see, do we have any bad characters? I'll tell you right now, we do not. There are no bad characters in this whole thing, so we are good with that. Alright, now we can go ahead and we know that there's no bad characters. There's also a way to do this with Mona, which the buffer overflow room teaches you in Try Hack Me. I don't like it. I've noticed quite a few issues with it. I've always had problems with it and stuff, so I've never liked it. But we follow this guy down. We got our 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, all the way down. Okay, a lot of times if there's a bad character, you'll see like 20 will be a bad character, or I'll replace 20, or from 20 and beyond, it'll all be broken. So those ones are the easiest, right, when it's all broken, because you realize, oh, okay, that's just all broken. The problem with them, though, is that, let's say X08, that's a lot of times a bad character. So it might break like at X07. So you get rid of X07, you get rid of X08, you get rid of X09. If I get rid of X08, then the whole thing works. And then you have to slowly add these guys back in. So the X08 and X0D a lot of times are bad characters. So that's just something to look out for, along with X20. And obviously X00. Alright, so let's go ahead and we will hop back into my Kali machine here, and we will write an exploit. We know there's no bad characters, right? We know the jump point. We can control the EIP value. We know where the buffer overflow is happening. Now what we have to do is create an exploit. And we can create an exploit. This is the real simple one that just pops calculator.py. But since we're still in Windows, we'll actually exit out of here. Exit, exit, exit. And we'll just go ahead and open up Dawn. Alright, we'll just run him. He's going to be running, and we're just going to see, can we pop calculator.py? And that's a good way to show a proof of concept. Like, hey, this does obviously work. So I'm going to go ahead and do an MSF Venom. Attack P. Windows / execute command calculator. Our bad bytes is X00, so we don't want those anywhere in our programming. And I like to write it in C just so I don't have that buff plus equals all the way down if you write it in Python. So I've always just done it in C. And then from there, we can grab this whole thing, or Ruby. Ruby's also going too. If you want to do it in Ruby, you can do RB. And it'll take it. Python will take that. And Python will also take C and Python. But yeah, here's a Ruby one, like right here. So, see how it already has a plus at the end there? That's why I like the Ruby one. But we can go ahead and grab this guy. Instead of bad bytes, we'll do a buff. Actually, we can just say shellcode. Buff plus equals shellcode. And then we'll put our shellcode up top here. So we'll say shellcode. Actually, we'll put it underneath there. There we go. shellcode equals, there we go, put some brackets around it. There we are, so that encompasses that whole thing, right? I also like to just make sure and just do this. We'll save him. So now what's happening is our buff is going to be plus or equal to shellcode. It's going to look at that shellcode, it's going to run that guy, and hopefully it's supposed to pop calculator.exe. Let's go ahead and make sure that does. Let's go ahead and do a buff plus equals, and we'll try to run some null bytes in there. So that's x90. Let's say 16 null bytes. And that'll kind of make that Mmap sled coming in, right? I said null bytes, it's not null, but you know, your well, they are null, but your Mmap sled, all right, that's going to make that so it slides down into that exploit, right? So we'll kind of do that, and let's fire him off and see. Okay, it did not like that at all because I don't know how to put a multiplication sign in because I suck. All right, there we go. John Hammond would not be pleased. We'll go ahead and fire that off. It's fire that missile. And we will go back to our Windows machine here. There we are. And as you can see, Dawn closed, calculator opened. So now we know 100% yes, we can exploit this. Okay, we just pop calculator.py. Little bit of a problem with the actual Dawn box though. If you send that off, nothing's going to happen. If you send off a reverse shell for Windows, nothing's going to happen. So why is that? Let's go ahead and see if we can get Dawn actually up and running this time. If not, I'll log out or I'll close out this whole thing, come back in, and we'll see if we can do it at that time. But yeah, why wouldn't we be able to get Dawn up and running at all? So I'm gonna wait, actually see if anyone in the chat wants to answer that one. Why we did everything on Windows, we did it all worked, but if we send a reverse shell at Dawn right now, it's not going to work. 100% will not work. You might get a little quick blip, but that's going to be about it. And why do you guys think that that is? About 10 more seconds. Actually, in about 30 seconds, we'll figure out why. Hopefully, if this box actually connects this time, we will. Alright, we got an IP address. Let's see if we can actually do anything with it this time. Do a ping. Nothing. What is going on today? Am I on a network? I'm obviously on network. What is happening today? I'm going to go ahead and I'm going to exile this whole thing. I'm going to hop back into him and we're going to try again. Because he is being super weird like right now. Go back into Proving Grounds. Let me play. Let me go ahead and you guys are going to look at the Windows machine for a second so I can go ahead and sign in. Alright, you come back to me. And hopefully we get something with this one. Because, yeah, no, I do have the VPN up and running. You can see that, like, right here. Right there. We can also see it over here. Because it says connected. So we know the VPN's up and running and everything. This guy just doesn't want to play today. He just does not want to do anything today, huh? I don't know what's going on with him, like, right now. There's no... You can ping him. There's not anything that says like you can't ping him. Because there is a port on here that should be up and running. Unless he's broke. He might have broke. Is Dawn 2 broken? Uh-oh. If he is, we're going to go ahead and move on to the next one. Now, once you get into Dawn 2, there is something you do have to do though. But the answer to why it won't work is because Dawn 2 is a Linux machine. Even if you didn't know that, you could always do an aggressive scan on it and an operating system scan. So you have to actually do a Linux reverse shell. So what you have to do is a MSF Venom, TAC-P, Linux x86 shell, and pretty much the same information that you would have. Alright, so whatever your L host is, your L port, and then an exit function equaling thread, just so it exits more nicely. And that is how you would actually get that guy up and running. I think Dawn might be broken like right now. Dawn 2. So if he is, we'll go ahead and we will look at another exploit that I just had to do that I thought was a ROP exploit, and it was not. It lied to me. So it's going to be the same exact style thing that we're doing here, except for instead of actually like firing it off from Windows and everything, or from Kali, we're going to do everything right from Windows pretty much. Pretty much close, I think actually every single thing straight from Windows, except for at the very end. What's going on? But then how is an executable file running? The executable file is not running on it. The executable file I already took. I had the executable. That's mine. I already grabbed it down earlier to get everything ready for this video. And yeah. He's can I revert? Yes. Oh, let's try this. Let's try to reset the whole machine. No, but the executable file though, I already grabbed him. So whenever you very first get onto him, there is port 80s open. You can go there, and then if you do another Rust scan or you just keep scanning him, you'll finally realize there's this port 1895 open, and there's another port that you'll see that's very random also, and that's for Dawn Beta, and that's once you actually get into him. So one of the boxes is for local, or yeah, local.txt, and the other one is for proof.txt. Let's go ahead and revert him and see if that works. Yeah, you never want to do a buffer overflow on the actual machine itself. You always want to try to get that file back down to you, start up on your own machine, and then do it from there. You never want to run it on itself, because if you break it and it doesn't automatically come back up, you're kind of SOL. It's not coming back up until someone reopens it. So you want to make sure that you have all the steps done beforehand, so that you can ensure that yep, can't revert it. Nothing, man. Nothing at all. That is super strange. No pinging. VPN is connected. It even shows I'm connected over here. And I am not getting anywhere on this guy like right here. Can't do anything. I could rate difficulty for them. 2. We did the buffer overflow pretty quickly. So it looks like this guy, we might just have to exploit the rest of him tomorrow, or I'll exploit Dawn 2, the other one, the beta file. So let's go ahead and fire up that one, and we'll exploit the beta file in here. What is that? Okay. So let me exploit the beta file, and we'll start to work on that guy. So that whenever it does finally come back up online, we already have our exploits created, and all we have to do is just kind of change out the IP addresses there and change out our actual shellcode. So let's fire up Dawn Beta. We'll run him, and let's do another Mmap scan. Mmap of 0.36, is that correct, or was it 35? Try a Rust scan. .35. And then we get this port 1435, which we know didn't exist before, because the lowest one that we had in the thousands was 1985. That was the only one that we had in thousands. So now we have port 1435. And if we go back, nope, you guys didn't see any of that. You're welcome. All right, there we go. Rust scan, port 1435. And as you did see in Windows, though, it just closed out, right? That Dawn Beta just exited out. So we know that for a fact we can hit it and it exits out. So let's go ahead and reopen it in Windows. Now on Dawn 2, just so you know, there is an actual, so there is like a cron job, we can say, that'll start that box back up again. Alright, so don't think that just because you Mmapped it or pinged it or anything like that you're screwed. That's not the case. Yep, still nothing. I think Proving Grounds might be broken today, or at this hour. So we can grab our same exploit that we already used. We're just going to grab him, because that's going to be kind of like what we're going to work off of there, right? Go to File, New File. Go ahead and paste him in there. Maybe we won't, because for some reason Sublime Text is not like Control-C, even though it says the copy is Control-C. We'll do Control-V. We'll get rid of the shellcode for now. Alright, we don't know what the offset is yet, right? So that's going to be 0. Our port has now changed, right, to 1435. Okay. We don't know what the jump point is anymore. So we can get rid of that. We can get rid of this guy. We don't have any shellcode. We don't know if we still need to run this or not. We have no idea. We're going to try it without it, and then we're going to try it with it. And we'll say, hey, we're going to say, you know what, A's, I want to send 50 A's at it. Because it is a beta one. And so it's probably much weaker than the one we just had. Right? I mean, that's what would make sense to me. Let's go ahead and call this exploit 2.py. We'll overwrite him. Yeah, we'll replace him, whatever. Alright, so now we have our exploit 2.py. And we have that guy up and running in Windows already. And let me go ahead and actually get him in Immunity Debugger. So let's get us back to Windows here. And we'll throw that guy into Immunity Debugger. Yes, please. File, open. Oh, it's just F3. I always press Control F3 and I always get like, why won't you open? And then F9. There we go. Alright, so that guy's up and running, right? And let's go ahead and fire this off. And I'm going to show you something after this too, because we can fire all this off just in Windows also. So I'm just going to fire off exploit 2.py. I know you guys are looking in there like right now, but we're just going to see, does he break? That's all we're looking for like right now. And he does. He's paused. Alright. But he didn't really pause where I wanted him to now, did he? So, like I said last time, we might actually be going too far. Okay, that was a Shift F9, so you guys know. So we did break him, but nothing happened in here in the EIP value. Let's go ahead and only send like 25 bytes this time, because we may actually be going too far and breaking him so much that he doesn't know what to even report. That's the thing. That's why whenever you do break something, if you do actually break it, you may want to back up and make sure that, yes, it is actually broken at that spot. And that's also why we do those B's afterwards, not just, oh, I broke it. Alright, so we got hop back into here. And we'll do a Sublime for exploit 2.py, right? And let's go ahead and change this offset to 25. So we're going to do buffer equals A 25 times. You know what, actually, I'm not even going to have offset in there. We're just going to do this like right here. We're just going to say A times 25. That's what we're going to say like right there. Alright, we'll do the offset afterwards. Control S. And let's fire him off again. He's already up and running over there, right? So we'll fire him off again. And let's check it. Amazingly enough, for some reason, we still did not break anything, which we should have. I'm wondering if the exploit.py, the second one, is getting confused with something here. Because he is paused down here. What happens if we pass an exception? Pass the exception, we're not seeing anything in here, so that's kind of weird. That's really weird to me, like right there, that we sent off all those A's and we're not seeing anything. Did I ever change that port address? 1435 buffer is A times 25 times, which that should have broke it. The IP address, that should be correct for 192.168.0.35. So I am a little bit confused like right now, because that should have broke that guy. Go ahead and do an IP config. 192.168.0.35. Okay. And let's actually, I don't know, I guess we're going to go up to, yes, F9, get him up and running again. And, oh, you know why we haven't broken him? Maybe we need to send out those null bytes with it. No one in the chat. Redownload VPN. I will do that here in a second. That's a good idea. We did not send out the null bytes with it, which is most likely why we didn't break him, right? So let's head back over into Kali and put those null bytes after that buff. Buff plus equals. Remember I said I don't know if we need them for this one or not. Okay, let's go ahead and save him. And let's try to fire him off. Python exploit 2.py. Remember we're only sending off 25 bytes this time. And he's still... Oh no, he broke him. Okay. Okay. You want to know what the problem was, I think? I think it was because he was running in the background. And I think we were just breaking the actual machine itself and not DOM beta. Control or F9. So I'm going to try to fire him off one more time because I just looked at it. And it all looked a little fishy to me. And still, it does not want to break this time. That's kind of weird to me. That is very weird to me. So we're just going to, you know what, screw it. We're just going to send off 1,000 and see if it actually breaks. Alright, so let's go ahead and send off. Oh, God, I did an X90. I'm so used to not typing X00 that I did an X90. Where are you at, Shizbadge? I thought you were going to get that one. Alright, so X00. There we go. We'll send that one off. We finally, I think, we finally have the exploit correct. I think. Hopefully. All I'm doing over in Windows is just getting him back back running with an immunity debugger. Go ahead and have pop back over into Kali here. Python exploit 2.py. I'm going to send you guys over to Windows first. I'm not even going to look at it this time because I'm scared. Alright, did he break? Did he break? He broke. Okay, so we got our 4 ones there. So let's go ahead and do a Mona pattern underscore create. And we'll say 25, I think it was, or 50. I think we said 25, right? Odd size. JS pattern will be truncated 24 bytes. It's even better. It's better used in even size. Okay, I'm sorry. I'm really sorry about that. I'll do 24 bytes. Actually, that is true. So we'll just do 26. How about that? Because we know it broke at 25, so we'll do 26, just in case if it's actually 24. So let's go ahead and copy this to clipboard. We'll copy the message to clipboard, like right there, right? That whole guy, like right there. And we'll head back over into our Python, or into our Kali. Do our Sublime exploit 2.py. Instead of buff equals that, we'll do a buff equals our pattern create. We'll send this off. Let me go ahead and make sure that he's back up and running inside of Windows. And we'll send him off and hopefully get something back. Alright. Let me hop back over into our Windows machine. And then I'm also going to show you guys at the end of this one how to do everything just straight from Windows. So we did our Mona pattern create. Now let's go ahead and do our Mona pattern offset for this IP address, or this address right here. Control V. It looks like we have our offset of 13. So we can update that now, right? And we can also do a Moda jump tac RESP, right? And we can grab that, so we know 13, and we have one jump. So it looks like no matter what we want to do, we're using that one. We have no choice. So let's go ahead and grab that address, and it's 13 is going to be our position. So let's hop back over into Kali here, and we'll do a offset of 13 this time, right? And then we also have a jump point of that. So we'll go ahead and delete him. 13 buff equals A times 13 times the offset. And then we're going to do a buff equals BBBB. Buff plus equals, excuse me, buff plus equals. And we'll do a buff plus equals C times, and we'll say 500. We'll go ahead and save that, like right there, and we'll see if that breaks the system and we get those 4 Bs in the EIP. Now we think we already have the jump point too, which would be nice if we do. So all I'm going to do is just get that guy back up and running again. Alright, he's back up and running. we'll hop back over into here and do a Python exploit 2.py, and I'm going to send you guys over there. I don't want to look. I feel like something's broken. Alright, so 424242, we're good with that, and we have a bunch of C's down here. So we definitely have a place to be able to put in our shellcode. Sweet. We are freaking crushing it like right now. So now let's go ahead and excuse me, find some bad characters. Right? So let's go ahead and start this guy up first. Yes. I've said let's go ahead about 8,000 times during this video. So I apologize for that. So we will hop back into my Kali machine. I also think I've said hop by 8,000 times. So I need another word. Yep, thank you very much. Cancel. Oh no, you don't have to retract the message. You don't. I saw it. I already saw it. I saw it. It already happened. But thank you. That was a good catch with the buff plus equals. I do that all the time actually. And then I click enter. And then it says like we can't run that. And I go whoops every single time. Or I like misspell buffer and like buffern. And something I do that all the time. So I'm used to going back and trying again. Alright, so let me go in that Sublime exploit 2. And we also need to create those bad characters, right? So we do a Python 3 bad characters.py. Go ahead and grab all those. We're already going to go with x00 as a bad character. And we'll go ahead and throw him inside of here, right? We can also stop that offset. Something else you can do. You can also, let me go ahead and do that actually. We're going to do that. So we can leave that there. And then we can say that, hey, this is going to be bad care, right? And then we can say bad characters equals that. That's something else we can also do. Okay, so we could just leave everything in there and just look at just the bad characters. We can do that with the jump even. So we can say buff plus equals jump. Okay, then up here we can say jump. And then equals, and then we'll do our /x, and it's really just however you want to do it, /x13 /x15. And there's also, you can also make it so you don't have to actually do this part too. You can actually make it so everything will do it for you, which in tomorrow's video I'll show. If I'm doing a video tomorrow, I don't know, I might be actually taking a test tomorrow, but we'll see. So we're going to do that. Okay, we're going to throw all of our bad characters at it. We're going to throw C's at it, and then it's going to go ahead and quit. We may not want to throw the C's at it, or yeah, we're not actually going to throw the C's at it like right now. We're just going to say, nope, we're not doing that, because I don't want to break it and then go to quit and it doesn't work. So that's why I'm not going to do that yet. So what we're going to do now is we're running our offset's going to be 13. So we got our A times our offset. So 13 times A times 13, right? Then we're going to do buff plus or equals to jump, which is this guy right here. We're going to do our buff plus or equals to bad characters, this guy right here. And then we're going to send up that the x00. So that null byte, like right there. And he should already be up and running, correct? I think I started him. I think I did. We'll find out here in a second. Yep, I did. Okay, so I'm going to send you guys over there first, because I'm way too scared to do this. And we will look at my ESP, right click, follow and dump. And here's all of our bad characters that we just sent off. So we got 1, 2, 3, 4, 5, 7, 8, 9, 10, blah, blah. It keeps going, right? And it goes all the way down to FF. I'm going to give you another hint. There's not any. So there's no bad characters again. Alright, instead of going through this whole thing and trying to find all the bad characters, there isn't any. That if you're doing anything with INE, that's not going to be the case ever. There's always a bad character, it seems like. Or like 7. Alright, so let's go ahead and let's build our shellcode now, right? So we can build our shellcode. Let me get you guys back over to me. There we go. We'll build our shellcode. So we'll say MSF Venom, attack P, Windows / execute command calculator. X00 is we're going to say a bad character. And we'll drop into C programming. We'll do a Sublime exploit 2.py, right? And we can go ahead and say, hey, that bad characters, you don't exist anymore. Okay. And you're actually going to be replaced by shellcode. That's C. Right? Alright. That guy, he's not being ran. We can go ahead and go to jump. we can say buff plus equals a Mmap sled there, x90 times 16. We'll do just a regular Mmap sled there, and then we'll go ahead and tell it what our shellcode equals. So we'll shellcode equals, this is turning into a pretty ugly program like right now, but that's okay. It's just a lot of crap on there, that's all. I guess it's good if, like, you know, you've never, what in the hell, why is that in there? Oh, it's going to be miserable. There we go. You don't have to do that. I'm just doing that to clean it up, which I guess it won't even really matter at all because of how ugly everything else is. So let's try to fire that off and see if it actually pops calculator. I'm going to now bring you guys back over to Windows. We're going to go ahead and exit out of Immunity Debugger, start up DOM Beta, run that. Hopefully it pops, or else I'm just going to look like an asshole, which I'm probably just going to look like an asshole. And I'm going to send it across. And yes, I look like an asshole because I again forgot to put times 16. I said x90 16. So times 16. And we'll send that again. And hopefully it popped. It did. Cool. So there's calculator. Alright, awesome. So that worked. Now, another thing you can do is you don't have to do any of that in Kali Linux. Because everyone always shows you it in Kali Linux. But we can take that same exact thing. Alright, so let's go ahead and I'm just going to cat this and I'm just going to copy it. Alright, I know you guys can't see it like right now. It's going to be real super quick. I'll do exploit2.py and I'll cat exploit.py. And so we could have built this whole thing out on Windows. So this one is exploit2. Let me go ahead and get back over to Windows. And I have Sublime Text on here, and you can also do it with Notepad++. So we'll do Notepad++, Sublime Text, or really anything you want to use. I accidentally opened up Notepad. We're just going to open up Sublime Text. Alright, as you can see, here's my VU exploit, like right here. Alright, literally have an exploit that I was going to do. This was supposed to be the ROP exploit, but it actually just nothing happened with it. Like it wasn't ROP at all. So let me go to new file, and we're just going to throw that in there. And then we're just going to save it. Save as exploit2.py. Alright. Our repeater just can be 127 or, you know, just stay the same. And everything can stay the same. We're not trying to call back to anything. We're not doing reverse shell yet or anything like that. So everything can stay the exact same. And I can literally just, there's exploit2. And as long as he does the same thing, I should just be able to run exploit2 and calculator pops. So, and you guys, yeah, you guys can see all that. So, and calculator pops open, right? Do the same thing with exploit1. This isn't some like magical thing that I'm doing here. Not doing some like, oh my goodness, you know, like witchcraft. So I'm just going to copy exploit1 now. Copy him. We'll bring him back over into Windows. We'll call him just exploit or exploit1, whatever you want to call him. Save as. We'll say exploit1.py. And as long as I have Dawn open, right? Go ahead and run that exploit1, and I popped another calculator right here. So you can run it in Windows too. There's no reason, there's nothing saying you can't. Okay. Actually, if I run VU player, and then I run this VU exploit, like right here, he's actually going to build a whole nother file. See this VU exploit file is build, and I put him in there. He pops a calculator. I have more calculators on the damn screen. Windows 10 doesn't even have calculators, I don't think, anymore. So there you go. Okay, so I like those ones. I like these ones a lot. So I'm going to do that one more time because I think that's super funny. So there's the VU player. Yep, we send that down, and he goes ahead and whoop, whoop. Okay, cool. So I'm going to re-download the VPN. Like Siobhan said so. Okay. Shivanish? Is that how you say it? Shivanish? You let me know. Alright, so I'm going to re-download the VPN for Proving Grounds, and we're going to try to get back in there, because now that we have the exploit, now all we have to do is just set the payload correctly, change the IP address, and we'll be up and running with that exploit right there. So that'll actually be super easy, and that'll only take a few minutes once we get that actual, you know, once you get that guy there. So let's download VPN. We're going to re-download this. I'm going to move into, actually, I think it's in downloads. Whoopsie daisy, not moving in downloads. I'm going to remove tech RF from downloads. And it should be Proving Grounds, OSP like boxes, overgrown carrot 1, open VPN. I think it's that one, like right there. No, that might be for try hack me. What are you trying to download? PG Open VPN. So where's PG at? Is that guy even in here? Yep, PG Open VPN. We're going to remove him, just so whenever I download this new one, I can keep running the same bash script and it should work. So we say OK. And I should be able to do a bash Proving Grounds.sh Cali, and he should go into it and find, into downloads, and find that guy. Alright, re-download him. Let's go ahead and try to play him again. And hopefully this works. Hopefully this does work. Yep, okay, so Shivanish. Okay, crushed it. I don't remember what the last one was. While we're waiting for that guy, we're actually going to look at our IP address, ifconfig, and we'll say, okay, that's who we want to call back to, right? Now, I said that this box was a Linux box. So let's go ahead and do an MSF Venom now. Tag P Linux, x86 reverse shell, no bad bytes. We'll write it in C. Exit function equals thread, right? It is not, we are now .74. And we'll say that our L port is 1337 because we think that we're cool and lead, right? MSF console, tag Q. We'll go ahead and run this guy. We can just do an NC LVMP. Alright. We also got a different IP address over here, 74.12 this time, which I actually like that one a lot more. So let's go ahead and do a use exploit multi-handler. We'll set our payload as a Linux x86 shell reverse TCP. We'll set our L host as 192.168.49.74. Whoa, wait. Do I have two tunnels up now? I do. Shish kabang. We'll try that one, because tunnel 1 should be the newest one, I would think. And this guy's .74. Let's try that one. Set our L port to 1. If it doesn't work, then we'll know, what's wrong. Hopefully. Alright, so let's go ahead and try to ping this guy. So we'll try to ping him like real quick also. Nope, it is just this box. Has to be. Has to just be this box like right here. I'm going to totally exit out of here. I'm going to copy this and I'm going to totally exit out of here. So now all the VPNs should be shut, right? Yep, it should say, hey, you just lost your VPN. You freaking idiot. We're stopping you and everything like that. Your VPN's been disconnected. And we are going to reopen VPN. And we are going to try one last time, and this one is just for Shivanish. The space, I'll show you Shivanish. If it actually works, I'll show you. Well, actually, I can show you right now. The space actually doesn't matter. Ready? I click new window, so we can do a ping, right? Because I did delete it. 192.168.0.35. I think the other IP address is, right? Okay, there's that, right? Are you ready? Ho ho! No, because I did delete the space a couple times. I was like, oh, maybe that space is messing with it. So I did delete it back a couple times. And yeah, it just did not like it. I'm just going to type it in straight up this time. So we're just going to do a ping. And we'll see what the IP address says up here. Let's go ahead and clear that out so I can actually read it. Ping 192.168.214.12. Went back to the same one that I used to have. And I'm telling you, Dawn 2's broke. It's just broke today. That's all. It was working earlier. It's broken now. You guys do know how to exploit it. You guys understand how to exploit and everything. So you could technically just take the information that we just got and exploit it like that. I would have liked to exploit it so I could have actually put the flags in. That would have been nice, but looks like it's going to be for another day. But all you would have to change is just this IP address, really, because you'd be going out to there, right? And you would have to change your shellcode out. And that would be it. Whoopsie daisy. And then it's stopping again. Every time I click on it, it stops. So there is definitely a problem with that, like right now. And then saying that I disconnected from my VPN, I didn't. So there's definitely an issue like right now. Your VPN is connected. Something's going on. I wonder if any of the other boxes are working. Like Lampio, I don't know. Play. Are you working? But yeah. Alright, the space that you can copy was wrong. Character. Okay, I see what you're talking about. I wonder if maybe it was just let's try to see if Lampio's on there. And yeah, other than that, that's really about it. Unless someone wants to play King of the Hill for like 10 minutes. If you do, let me know. I will start up a game real quick. You know I like those, so I will be all over that. And Lampio, so as soon as it starts up, it seems like it's being disconnected again. I know it's not my internet, so if I go like try hack me like right now, I can hop onto there. Give me my guy's old email, I don't care. I don't care if you guys have my old email. But and I can hop onto here and do whatever I want to. Bash scripts. Yeah, so that's working just fine. So I don't know. I don't know why. But we'll try again later. We'll try another day or something like that. I may be streaming tomorrow. I don't know yet. But come hang out. And it's good to see everyone. And you have a good night. Alright, thank you, Hoss, for the, oh Jesus, for the 15 different fouls from the same Hoss. Alright, so welcome back. Oh yeah. The username is like different, like each time. But this is pretty funny. Oh my god. We're gonna have to like shut it down, Hoss. I'm sorry. We have to like turn it off so like you can't see it. So that we can actually do this. There we go. Sorry, Hoss. For the 40 fouls later. Thank you. Alright, so I got back into Dawn 2, right? And we already did this one once before, and also want to say real quick, good luck to Deepak 25R Cyber Freak. There you go. Alright, he's taking his DJPT exam tomorrow. Good luck. If you're part of Discord, let me know. Let me know how you're doing stuff, and hit me up. So we started Dawn 2 again. Now, really, I haven't actually even tried to ping it yet. I probably should have done that beforehand. Let's see if it works again. Alright, so Dawn 2 is working again. So if you remember from the last stream a couple days ago, Dawn 2 decided to stop working. So let's go ahead and look at what we did during the last stream. Alright, to go into the Sublime Text, exploit.py, and right here we have our exploit, right? So what we have here is we saw that Dawn 2 had something open on port 1985. We also saw that Dawn 2 had an IP address. Well, we had this IP address and we could download something from there, right? So we could click here, it would download that dawn.zip. That dawn.zip gave us an executable, which we found out was a buffer overflow that with 272 bytes, and then obviously our jump, our NOP sled, and then our shellcode, we could pop, I believe this one's for calculator.txt. So that was our last stream, and then Dawn 2 broke. So we're going to get back into them today and see what we're going to do after that. I already have both the exploits up and ready. I'll show you how I figured out that second exploit once we get there, and from there we will we'll go ahead and see what's going to happen here. So let's do an Mmap scan first on 192.168.216.12. Okay, so we get port 80. Let's go ahead and actually do a Rust scan also, because we're pretty sure the ports could be high up there. And we get port 1985. We also have a port 1435. Now if I were to stop this and I do that Rust scan again, those ports are gone. That's weird. Okay, the reason that's happening is because once you connect to those servers, they connect, they disconnect, they reset, and they open back up again. So if we do it again, they may come back, they may be gone. Okay, 1985 came back, but 1435, one that we just saw, that one's still gone. So where did that one go? What is that? So let's go ahead and let's try to do something with 1985. So we have this IP address like right here. Now we do have to change up our exploit because we downloaded that exploit back to our Windows machine, right? And then we ran it from there. So, and that was all in the video right before this one. And I'm probably just going to combine these two together, and we'll go like that. So let's go ahead and change the IP address up here to who we are actually attacking, right? So far we're good. And let's go ahead and do a shellcode. Now, we are on a website. This is not IIS, right? So if I look here, this is, as far as we know, this is not IIS. Okay. Nothing in here is telling us that it's IIS or anything like that. So we're pretty sure we're probably on a Linux website. And if we actually do an aggressive scan, it'll show us, it'll tell us that we are using Linux. But this whole time, there you go, there's port 1435 up again. This whole time that we have been attacking something, we've been attacking a Windows machine. So now we have to kind of change up our exploit like a little bit. So we have to do an MSF Venom, attack P Linux. All right, we're just going to throw a guess out there and say that we think it's an x86. All right, we didn't find any bad bytes last time, so the only bad bytes could be x00. We're going to write it in C programming, do an exit function thread just so it closes out more easily. We'll get my IP address. Config, and right now I am also 192.168.49.216, and then we'll have a listening port. So let's also go ahead and start up MSF console. We could just obviously use also a netcat listener. All right, so we can get that guy in there, and from there we'll also set up. Let me get this full screen. I don't know why I'm doing it like that. We'll also go back to Sublime Text for exploit.py. We can grab that shellcode that we just made, and let's go ahead and throw him into here, replacing what we put in there for calculator.txt. Everything else is still the same. The offset's still the same. The jump points are still the same because it's still the same program, right? So everything else could still be the same as long as this jump point isn't something that you actually took off of like findjump.exe, which I've yet to have to use that. Unless it's something like that, then everything's still going to be the same. So let's go ahead and save that exploit now. Let's go ahead and down here do a use exploit multi-handler, right? Set the payload to a Linux x86. I think it's shell reverse TCP. Is that right? Shell reverse TCP. Set the L host to 192.168.49.216. Set the L port to 1337. And we'll go ahead and run that. Now let's try to fire off this exploit. So we're going to do a Python exploit.py, and we'll see if we get anything back. Hopefully we do, because I haven't done this one in a few days. So maybe, may not get anything back. We don't know. And we do. Okay, so we have a shell open now, right? If I do an ID, okay, right now I am Dawn. All right, cool. Go ahead and do an ls-tech-la. Okay, we can't do anything with that. Cat, desktop cat scripts. Right, SUID lookup, or full shell, I mean. Let's go ahead and cat those scripts for full shell. Let's do a which Python first. See if it's Python or Python 3. It's Python, so we don't break the box like that. Alright, and so far we've gotten in and we've been able to now get our reverse shell going, which cool. Okay, right, awesome. Oh, what's up, Al? How you doing? Alright, so now we have my phone's charging right now, Al, so I don't have my Twitch stream up next to me. Let's see if we do ls-tag-la now. We can. Alright, we can cat our local.txt now. Now, like I said, we did see something else, that port 1435 or whatever it was. We have an executable here, which we actually just got into a buffer overflow, right? We also have an executable right here. So what is that dawn-beta.exe? That might have been port 1435. Let's go ahead and hop back over to offensive security. We'll put a flag in there. Save. Alright. And cool, our flag was submitted. Now we have that port 1435, right? So let's go ahead and look at this guy's dawn-beta.exe. And I did bring that guy already back down to me. I already showed you guys how to do that in the last video too. So if we do an ls-tag-la, we have our dawn-exe like right there, or our dawn-beta, right? I already brought that over to the Windows machine, downloaded it. We already exploited that. And that was an exploit 2.py. So let's go ahead and cat, or we'll actually do a sublime so it's easier to read. Exploit 2.py. And then there's this one. Okay, so again, that's on port 1435. There's our jump. We did have a bad bytes for this one, I don't believe. Alright, I don't remember if we did. I don't believe we did though. And as you can see, we also had to close this one out and the last one with a null byte. In the last video, we saw that in a readme.txt file. Alright, so if I go over to here, if I cat that readme.txt, we can see that send a null byte at the ending of your message. So at the end of the message, we were supposed to send that null byte, which we did with the last one also. So let's go ahead and make another exploit for, well, we already have the exploit because we already did it during the last video. So let's go ahead and fire that one off. So let's do a MSF Venom, and this time we'll do port 1338. All right. Everything else will still be the exact same, right? There's no bad bytes in it, so just TAC BX00. And from here, we can have another listener and see TAC LVMP for 1338. All right, there's that guy. And we can copy him. Let's go ahead and go back into our Sublime there. We have to change the IP address and we have to change our shellcode. So there's that, and then the IP address. There's that. Right. And we can go ahead and save him now. And our offset for that one was 13. We did 13 A's. Then we did a jump. So there's our jump like right there. We did an op sled of 16 bytes. We threw in our shellcode. We just do it like right now. And then we ended it with a null byte. So now let's go back. And if anyone wants to see this whole thing again, we can do that later on and put the whole thing together. I'll try to make the videos so then they get put together like that. If I can find the other one, or if I even press record down here, which I don't think I actually did. Oh, I did. Cool. All right, so let's go ahead and fire that guy off, I guess. So we'll do a Python exploit 2.py. We'll see if we get callback over here. And we do. ID. And now we're root. So let's go ahead and cd/root. And we'll cat that proof.txt. So we made 2 buffer overflows for 1 box. Both very easy buffer overflows. And yeah, that's really it. Like I said, I'll put those 2 videos together for you guys. And then we'll go from there.